We can forecast what will happen in terms of demand for our product or complaints or quality issues, not necessarily with time, or we could with time, but we could also do the forecasting with some other variable. So when you're forecasting and you're using another related variable, this is what is called an associative model. So for example, let's suppose that our company is a small hardware store and we sell door locks. Okay, what we found is that there seems to be a change in our sales based on when the newspaper reports break-ins in town. So depending on the number of break-ins the newspaper reports, we see a different number of sales, which means we should be able to predict our weekly sales based on how many break-ins they talk about in the newspaper. So here you have our data. Here's our sales. Here's the number of break-ins reported in the newspaper. And so here on the graph, you see the number of break-ins, and on the vertical, the number of units sold. It's very important that whatever you are trying to predict be on the vertical axes. So how you would do this in Excel, you can see the other YouTube video on how to do that. But we're just going to look at the findings once we've found the relationship in Excel. So first thing we do in Excel is we're going to plot the break-ins and the number of units, and the number of units is on the vertical. When we do that, what we are looking for is we're looking for a relationship between our two variables, between the one we're trying to predict and the one that we're using to predict our data with. So we're trying to predict sales using break-ins. So we need the two variables to be related to each other. So essentially what we're looking at is what is called R-squared. This is the coefficient of determination. The coefficient of determination tells us the percentage of variation in one variable that is explained by variation in another variable. So R-squared is really just the square of your correlation coefficient that you talked about in stats, right? So you looked at how two variables were correlated. Well, the R-squared, or coefficient of determination, comes from squaring that number. So how much variability in sales can be explained by the fact that the number of break-ins reported in the newspaper is changing. We are looking for an R-squared of 0.8 or greater. So what we do is we take our data, we put it into Excel, we do a line of best fit, we have Excel give us a formula and report an R-squared. Okay? So we're looking for an R-squared of 0.8 or better. Now that we have this formula, we can use the formula to forecast the number of units sold. So here, we're trying to forecast, okay, and we can use a y hat for our forecast, and that's going to be equal to 4.2753, and then we have x, which is a placeholder, not for time, but this time it's for the number of break-ins. So we're looking at 12 plus 7.1292. So we can figure out how many units sold we are expecting to see if 12 break-ins are reported in the newspaper. So we do this calculation and we end up with 58. We can actually get Excel to extend out this linear trend and show us that at 12 we would be at 58. So we can do a visual as well. So associative models take a related variable, and instead of using time to predict what will happen, we're looking at what's happening with that other variable and using it to predict what we're going to see.